Problem, which one did we say?
33.
Problem 33. I'm not even reading the problem, I'm just looking at the picture there. They give you a picture, it looks something like this. Does that look about right?
Yeah.
That's x, that's 5.5. This is 6. The right angle there, so that's an altitude. We had that altitude theorem last time. Said that the altitude is the geometric mean for these two parts. So remember, when you're doing that, the altitude goes here, here, and then the two parts, part 1, part 2 goes there and there. So tell me, how am I going to set up this proportion? What goes here?
6 or 5.5.
That can go there. What goes here?
6.
That's the altitude, right? This time we happen to know the altitude. What goes here?
6.
And then what goes here?
X.
We cross multiply, we get 5.5. X equals 6 times 6. Somebody divide that for us. 5.5 or 36 divided by 5.5.
It'd be 6.5.
And I think our units were feet, weren't they? So 6.5 feet. If for some reason, I don't know why they would have, but if they'd asked you to find this, several different ways you could do it. Maybe the easiest way, Pythagorean's theorem. I'm doing Pythagorean's theorem because hint, hint, on this quiz, guess what you're going to have to use? So if we were trying to find this is a leg, that's a leg, that's the hypotenuse, and we would just set up 6 squared plus 5.5 squared equals y squared, and you would solve that. Other question?
28.
You said 30.
No, 30. Fine. Sorry.
What?
Is that right? All they tell us this whole thing here is what, 25, is that what they say? If that whole thing's 25 and this part's 6, what do we know about this part?
That part's 19.
So let's put it in there. X is the what again in this case? I thought I heard it. What is it?
Altitude.
Altitude. So when I go to set this up, remember it's altitude goes here and here, and the two parts go here and here. So what's going to go in the top here? You can pick whichever part you want. It doesn't make any difference. 6. What part goes down here then? Then what goes here? What goes here? Cross multiply x times x is x squared. Somebody help me out. What's 6 times 19?
114.
What do we still have to do to get our answer there? Take the square root. What's the square root of 114?
10.67.
10.7.
Yeah.
So that's x. We want to find y. Y, instead of being the altitude, y is a leg. And so is z. So they're going to be set up the same way. Remember, with a leg, the leg goes here, the same leg goes there. It's the geometric mean for the part hooked to that certain leg here, and the whole hypotenuse there. The whole and then the part. So if I'm setting that up for y, let's say this time, we know y goes here, y goes there. What's the part hooked to Y? How long is it? It's that right there, right? It's just that part hooked to it. And what's the whole hypotenuse? How long is this whole hypotenuse in the big triangle?
25.
That goes there. You cross multiply, you get y squared equals, somebody help me out.
150.
Now what?
Find the square.
What's y equals square root of 150?
12.2.
12.2. Anybody else get that? Now, we still have to find z. Same idea on z. You're still going to use this same thing. Don't make these harder than they are. Look them up in your notes and use them. Where does z go in this? In our proportion here. If it's a leg.
Bottom left and top right.
Bottom left, so, no, I was getting ready to write leg. So z goes there, and
Z.
z there. What goes here? What's the part hooked to the z?
19.
And what's the whole hypotenuse?
25.
We cross multiply, what's z times z give you?
2 squared.
19 times 25.
475.
Say it again.
475.
And what do we do to find z?
Square root. 21.8.
Alright. Didn't leave myself enough room to put z there. Those are the three answers.
Would it be okay to keep this in the simplified square root form?
Yeah, you could.
I'm very confused
On what?
on the quiz.
Some of Martha diagram triples.
Oh.
Alright, on this quiz, should only take you a couple minutes. You want me to put X's in here? You're finding an X there, X there, X there. I'll give you a little hint. These two, you can use the triples on and you really don't have to do a whole lot of work. So you can find the answer for X on those two fairly easy. This one, you have to use Pythagorean's theorem. You have to set up a squared plus b squared equals c squared and solve for the a or b or whatever. Take a minute or two, do that. Get finished with it. I know it says turn it in on the metal stool. You can probably figure out that it's not the metal stool, it's the tray, right? Do me a favor. Look on the notes and stuff up there. Tell me what section it says. 9-4, is that right?
Yeah.
Thank you.
We need this today, right?
Yeah, we're going to get in there. quiz, just keep it, keep out the worksheet, we'll do a couple more problems off of it. Just try to refresh your memory before we go on to the next thing. Gentry, do you see me setting up here during the intervention? Did you see how long it took me to do this packet? Probably maybe 10 minutes, and that was you. You know how it is. Everybody interrupts me all the time. Or I have to yell at Kaylee because she thinks she's getting away with something. She's looking at her phone behind her. Driving me nuts. Do you understand why I argue about you working with her all the time?
I do.
Okay,
I
so
was
make
trying
sure
to work
that's
with her and then I realized that my thing wasn't working and I lost all my progress.
I understand that you try to help her sometimes, but then when she sits over there and says, hey, Ebersole, you're stupid, you can't tell on my phone here behind my computer, that bothers me. Would that bother you? If people just treated you like you were an idiot or something, couldn't tell that they were doing something wrong at that point? On this quiz, first one, fits one of the triples, 5, 12, what's the hypotenuse?
13.
The last one also fits one of the triples, anybody figure it out?
17.
8, 15, and what? 17, do I just put 17 there?
Square. Well done.
17 times the square root of 2. This one, tried to trick you, it looks like it fits this triple, but can that side be 13?
No.
So what you have to do, you have to set up Pythagorean's theorem. This is a leg, this is a leg, that's what we're looking for, this is the hypotenuse. If you're not labeling these triangles starting today, you're gonna have to label them with the stuff that we go over today and here in the close future. So leg, hypotenuse, and we're gonna label them different things today with this. How would I set up Pythagorean's theorem? A squared plus b squared equals c squared. What's a?
5 squared.
Could be 5. What's b then?
X.
Okay, that's the one we all know, and that's, we said let it be x. Where's the c is always the hypotenuse, so what is it this time?
12.
You gotta make sure that you know where the hypotenuse is, it always has to go in that c. What is 5 squared? And some of you, I don't know, however you want to do it. Some of you like saying, all right, move this over to the other side, and you end up with x squared equals 12 squared minus 5 squared. Then you can just type all that into your computer or into your calculator. Somebody type all that in for us. Is that the way you guys have been doing it, or do you want to do it a different way?
That's how I've been doing it.
Maya, you've been doing it a different way? Just been going ahead and doing the squares and then subtracting?
119.
And then what do you do there?
Square.
Take the square root. Somebody help me out. What's the square root of 119? 10.9. So just to appease Maya here, you got 5 squared plus x squared equals 12 squared. That's 25 plus x squared equals 144. What do you do to get x squared by itself? Minus 25. Somebody help us out. What's 144 minus 25? 119. And you gotta take the square root, and it comes out to be, what'd you say, 10 point what?
9.
Fletcher, get with me tomorrow so you can take this quiz, all right? During the intervention. Other questions on the packet before you hand it in? 28. That's X, that's Y, that's 12. What's this called again? Altitude, good. This is 9, this is Z. I don't care how you find these answers. I know somebody last time in this class, I think it was Fletcher, he looked at this triangle that was over here on the side, and he said, hey, that's 9, that's 12, and that's Z, because he came up and asked me how to find X and Y, I think, and he'd already found Z. Could we use Pythagorean theorem just to find Z there? Yeah. I don't care how you do it. You can use the altitude theorem, the leg theorem, Pythagorean, whatever is easiest for you. This actually fits one of the triples. Anybody see which triple it fits? Fits into 3, 4, 5. This is the smallest leg. What do you do to the smallest leg if it matches up to 3? What are we doing to that to get up to 9? Multiplying it times 3. This has to be the other leg, so that's 4. What are we doing to it? Times it by 3. So on this one, this is the hypotenuse. It has to be the 5. What do you got to do to it? Times it by 3. What is 5 times 3? So Z equals, I don't know why I marked that out. Z equals 15. We could do it that way. You could do it using the leg theorem that we talked about the other time too. To find X, that's this part of the whole hypotenuse here, of that big triangle. So I'm going to do altitude goes here, altitude goes here, part 1 goes there, part 2 goes there. What is part 1 this time? X. Does it really matter which one of these is part 1 and which one's part 2? Makes no difference. What's the altitude this time? What's the altitude this time? Part 2? You put X here, then 9 has to go there. We cross multiply, 9 times X gives you what? 12 times 12. And then what's the last step? Divide both sides by 9. What's X equal?
16.
Now, once you know that that's 16, a couple different ways you could do this. This is 12, this is 16. We're looking for this. Could we use Pythagorean theorem to find that side? Yeah, 12 squared plus 16 squared equals Y. It actually fits one of the triples.
Yeah.
It fits one, sorry, I had something. Fits one of the triples again, so you could find it that way. Or, Y is a leg. Theorem that we talked about last time. Leg there. Part that's hooked to that leg goes there, and then the whole hypotenuse goes there. Which, there's 3 different ways you could do it. I don't care which way you find it as long as you get the answer. You're doing Pythagorean theorem again. 16 squared plus 12 squared equals Y squared. That's one way to solve that. You see it fits a family. This is, it fits the 3, 4, 5 family again. This is 3 times 4. This is 4 times 4. So that means the 5 over here has got to be times what?
4.
What's Y end up being? 20. If I do it this way, looking back up here at this original thing, Y is your leg, so Y goes here and here. The part attached to that Y is how long? We just found it. So 16 goes there. How long is the whole hypotenuse?
25,
How'd you get 25?
16 plus 9.
Just add those two together and get that whole thing. Cross multiply, what's y times y give you?
Y squared.
16 times 25. Grab your calculators, help me out.
400.
Then we gotta do what?
Square root.
Take the square root. Somebody help me out. What's the square root of 400? We got 20 that way. You told me that this was 20. If I'd done this, somebody do all that in their calculator for me. 16 squared plus 12 squared.
400.
Take the square root of that. No matter how we came up with it, how we did it, what y end up equal? 20. All kinds of different ways you could use this stuff. Pythagorean's theorem, using those two theorems that we talked about last time, the altitude theorem or the length theorem, setting them up in those proportions. Other questions?
31.
31? Is that what you said?
Yes.
Y, that's 3. This is 2. This whole thing is Z.
I did it.
This is X, is that correct? Set everything up right?
Yep.
What do you want to find first? You want to find Y first? Could find Y by using what? If I look at this triangle on this side over here, Y is right there, this side's 3, that side's 2. How would I set up Pythagorean's theorem? A squared plus B squared equals C squared. Which one's the hypotenuse? 2, 3, or Y? It's across from the right angle, right? So that's the hypotenuse. So Y would have to go over there. What's the one leg? 3. So 3 squared, what's the other leg?
2.
Somebody put all that into their calculator for us. Is 13 our answer? Take the square root. So what's y equal? What do we want to find next?
X.
X. X is right here. Can we use Pythagorean's theorem this time? Because if we set up Pythagorean's theorem, it'd be 3 squared plus x squared equals, this would be the hypotenuse, but we don't even have a letter over there, so we don't have enough information to do that. So what we can do here is use that altitude theorem. Part 1 goes there, part 2 goes there, altitude, altitude. Remember, your big triangle, this is the hypotenuse. In this case, it's across from that right angle. This is one of the parts, this is the other part. So what am I going to put right here?
X.
X. Then what I have to put here?
X. 2.
2, the other part, right? Now, altitude is the one that has to go in 2 different places. Well, we know the length of the altitude this time, so what goes here?
3.
And what goes here?
3.
We cross multiply, x times 2 gives you what?
Right.
You're right. 3 times 3 gives you, how we solve that? Do we have to take the square root again? Just divide both sides by 2, what's x equal?
4.5.
Remember, you're dividing by 2, not taking the square root. Don't get confused. So x equals 4.5. What's the easiest way to find z?
Add the 2 together.
Just add those 2 together. So what's z equal?
6.5.
6.5. Could we have found Z some other harder way?
Yeah.
Yeah, we probably could have. We could have set up the leg theorem where we use this leg and said 3.6 goes here, 3.6 goes there. The part adjacent to the leg is 2, and then the whole thing we don't know is Z. Let's see if this comes out right. It doesn't look like it's going to. Huh. What's 2 times Z give us? 3.6 times 3.6. Now what do we do? I don't see it right. 6.7.
7.2.
This is supposed to be 7 point.
12.96.
Yeah, that's supposed to be 7.2.
And multiply.
I did.
12.96.
You added.
3 times 3 doesn't equal 7.
Are you just trying to compute?
You're not adding them, you're multiplying. So
I
you
know
do 3.6.
12.96.
12.96. Now what do we do with that? Solve for Z.
Divide.
Divide both sides by 2. So divide that answer that you got by 2. What's it? What is it?
6.48.
6.48.
Close enough.
What did we say Z was before?
6.5. So it's pretty close.
It's pretty close. Make sure your names are on those. You're going to lay them right here on this desk. Grab the notes if you haven't already from up there. Is everybody finding everything all right? Everybody know where the square root and stuff is on your calculator? Fletcher, you're finding all the square roots and everything on your calculator all right?
Yeah, we went through it.
Watch out, Maya. Don't hurt yourself. Hey, Fletcher. I think the game's on.
Not yet.
What?
Ours isn't yet.
Talking about.
JV.
No, we don't. You know, never mind.
But I heard it's on new,
Pythagorean theorem again. Pythagorean theorem: a squared plus b squared equals c squared. Make sure you know that. I don't think this is on your notes, is it? I just stuck this on here. Go back over it. Please try to start remembering some of these triples, just so you can see it. I know there was one problem on the worksheet, and it looked something like this. Had a tree and stuff in it that said this wire out here that was holding the flagpole holding it up was 50 feet. The flagpole was a 40-foot flagpole, and they wanted you to figure out how far this should be. Anybody know how far that should be without going through a whole lot? 30 feet. Because it fits into that 3, 4, 5 triple. If you know no other ones, be able to pick out these. Those are the ones that get used more often than the rest of them. Special right triangles. These are the special right triangles. We're going to talk about them today. Trying to pull something over on me.
No, I just went back to where it said fast. No, I didn't even say any numbers.
It was the first 9 weeks.
Hey, Joey.
Grab this up here, Joey. Joey, there's a quiz you're going to have to make up for me. Special right triangles. Be able to find the sides and angles using a 45, 45, 90, 30, 60, 90 triangles. Those are the special right triangles that we're going to talk about. In these triangles, the main things, when you get one of these triangles, you've got to label the triangles. These are very, very simple if you label the triangles. If you don't label them, then you make them more difficult. Fill in what you need to fill in on this part. Also, Joey, I collected the packet from last time.
Joe, I'm pretty sure the game's on.
So a 45, 45, 90 triangle is also called an isosceles right triangle. If a triangle is isosceles, what do you know about it? It's got two angles the same, two congruent sides, right? In this, the sides, these two legs are always going to be congruent. So you might want to mark that on your triangle there. In these triangles, anytime it's a 45, 45, 90 triangle, again, label. You're going to draw labels on these every single time. And I always do this. The side across from the 45-degree angle, we can label it. I use this cursive L a lot of times. We can use X. It's just, we use X for everything. And so it gets confusing. So sometimes I don't like using the X. All right? Because there'll probably already be X's in there. And then poor Gentry gets confused about the X that he stuck in and the X that they put in, and are they the same? And so when I label it, side across from that 45-degree angle, I put that cursive L. Side across from the other 45-degree angle. If those two are the same and this one's the cursive L, what's this one going to be? The cursive L. The side across from the right angle is always that cursive L times the square root of 2. Now, if Joey doesn't like that cursive L for whatever reason, then he could label this side X, and this side X times the square root of 2. All means the same thing. If you want to use some other letter, go right ahead. I don't care. So if Maya wants to use M, she labels this side M, this side M, and this side M times the square root of 2, whatever. It doesn't make any difference what that variable is. What matters is that every time you see a 45, 45, 90 triangle, these two sides get labeled the same, and this side is whatever you put on these two sides times the square root of 2. It's that same thing every single time. Every time it's a 45, 45, 90 triangle. You've always got to label it first. Gwen, I'll give you a second to Julia, can you help her out back here? Since I've written so much other crap on here already, probably going to be confusing. Once you label it, then there's probably going to be, you're going to have to set up an equation. And you're going to solve that equation. Some of the equations will be real simple. It'll be like x equals 5. Well, there is nothing to solve. You just know x equals 5. And wherever you see x, you stick in a 5. Joseph, think you can handle that? Seem too difficult? I had all that on there. Look how fancy I got. Put motion in it and everything. Bounce down. That's pretty cool. So L times the square root of 2. Again, you don't have to use that L. Use whatever. I just like to use the L's because if you stick X in there, it seems to confuse people because a lot of times there's already an X in there. If you draw a diagonal in a square, and apparently I'm looking at your paper, I already drew the diagonal in for you, didn't I? So if you draw this in a square, no matter which direction it goes, guess what's true about these two triangles? They're congruent. What else is true about them? What kind of triangles are they? They're right isosceles. Isosceles right. And they're 45, 45, 90 triangles. So each one of them's a 45, 45, 90 triangle. So if I told you this side, I don't care, make up a number for me. 10. If I told you that side right there was 10. What do we know about this side up here? It's got to be 10. How about this side over here? How about this side right here? How about this side, this diagonal? 10 times the square root of 2. Every time. What if I had another square? Told you this was a square and I had this diagonal. And I told you that this side was 7. How long is this diagonal? 7 times the square root of 2. I have this square. We have that diagonal. And I tell you that this side is 4. How long is this diagonal? 4 times the square root of 2. I have this square and this diagonal. Tell you this side is 2. How long is this diagonal? 2 times the square root of 2. Fletcher, any of this sinking in? If I draw a square right here and I draw that diagonal and I tell you this side's 5, how long is the diagonal? 5 times the square root of 2. So on, so on, so on. For every square, you draw in that diagonal, and it's whatever the length of one of the sides is times the square root of 2. Every single square in the world, that works out. 30, 60, 90 triangle. What do you think you know about a 30, 60, 90 triangle? What do you know about a 30, 60, 90 triangle? One of the angles is how much? 60. One of them is 90. One of them is 30. That's why it's called a 30, 60, 90 triangle. So again, everything, first thing you're going to do every single time, label the triangle. And when I'm saying label it, I'm talking about going through and writing this in on the sides. See if I put action on this one or not. Yep. The side across from the 30-degree angle is always going to get labeled just L. Or, if you don't like using the L, X.
You put X on our papers.
Did I put X on your papers?
Yeah.
Really? I did, didn't I? Side across from the 60-degree angle. You got to be careful here. So the side across from the 60-degree angle, I always draw these arrows in. That side's going to get labeled L times the square root of 3 or X times the square root of 3. Don't get this confused with the square root of 2 for the 45, 45, 90 triangles. And the side across from the right angle, the 90-degree angle, the hypotenuse, always gets labeled 2 times L or 2 times X if you're using X instead of L's. So if I drew this triangle, told you that's a right angle, I told you that's a 30-degree angle. Every time you see a triangle that looks like this, first thing you should do, figure out that third angle probably. What is that third angle going to be? This is 30 and that's 90. What's this one have to be?
60.
Nothing hard about that. Then you're going to label it. Side across from the 30-degree angle. What's it get labeled with?
X.
The side across from the 60-degree angle. What's it get labeled with?
X times the square root of 3.
The side across from the right angle, the hypotenuse, what's it get labeled with?
2x.
You're going to do that first every single time. No matter what kind of problem it is, you're going to label the triangle with those 3 things. 45, 45, 90, you label it with X, X, and X times the square root of 2 every time. I can hear Maya's head over there going, well, I got to label them, Ebersole. It's easy stuff. I can do it without labeling. Why I got to do all that writing? Just don't mess it up. An equilateral triangle. Give you a second to write down what you need to write down here. What's an altitude again? What should you think of as soon as you hear the word altitude? 90 degrees, right angles. So if I draw an altitude in, how would I draw an altitude? From a point down, and what's it going to form when it gets down here? Right angles, good. So it's going to look something like that. It's going to have a right angles down there. When you draw that in there, these two triangles are both 30, 60, 90 triangles. We already know that that's a right angle. What's this angle up here, you think? 30. What's this angle? Remember, in an equilateral triangle, if I just draw an equilateral triangle here, if I tell you all those sides are the same, how much is each one of those angles? 60 degrees. So what am I doing to this angle up here?
Angle bisecting.
Angle bisecting, splitting in half. How much is this angle over here then? 30. This angle over here? Now you got two 30, 60, 90 triangles. The side across from the 30-degree angle, let's just look at the triangle on the left. What did we just say? The side across from the 30-degree angle should get labeled with what? L. Are you guys going to jump back and forth on me just to confuse me between L and X? Side across from the 60-degree angle should get labeled what? L times the square root of 3. Side across from the right angle? 2 times L. Looking at the triangle over here, what's this bottom part going to get labeled? L. So what's actually happening to the bottom there?
It's time to mix.
Being bisected, right? It's split in half. What's the side across from the 60-degree angle get labeled? Which we already have, don't we? You just did that, just smarter than me.
Yeah, I did.
Side across from the right angle gets labeled what?
2 times L.
Notice, this is 2L, this is 2L. How much is this whole thing?
2L.
2L. Now, all those sides in an equilateral triangle should be the same. Anybody ever seen an equilateral triangle out in the real world anywhere?
Nope. Well, maybe. Yield signs, I
How do you spell yield?
think.
The E comes first? You sure?
Yes.
Yeah, E is E-I-L-D.
I think you guys are wrong.
No, that is right.
Hold on, let me see.
The I's first.
Put the I
Pick the
first.
I.
The
That's
I's
how it looks.
first. Look. I's
No,
first.
the I and the L stay together.
Yield.
That
It's
is not
Y.
right.
It's Y-I-E-L-D.
How I remember it is I and L always stay together.
Apparently not.
I don't yield at those signs anyways.
Can I have my
Just look it
phone?
up.
Look.
Every time I see a yield sign, I want to take it, so. What? Dude, I put it in the room.
You can tell how much I don't pay attention to the yield signs.
Sam also doesn't obey. Stop
So
signs,
the
stop
steps.
signs.
I don't think I put these steps on there anywhere. Write them off to the side somewhere. You're going to write down all 4 of these steps. First thing, you're going to check, see if it is a special right triangle. Then label it. Then set up an equation. Then solve the equation. And we'll talk more about setting up and solving the equations here in a minute. 4 steps. Don't make this harder than it is. If it's not a special right triangle, then go back to Pythagorean's theorem or something else. One of those other things. But probably on like the homework tonight, guess what they're all going to be?
Special triangle.
Special right triangles, either 30, 60, 90 or 45, 45, 90. kind of triangle we got in this first one?
45, 45.
45, 45, 90. On your paper, doing this, side across from the, I'm not even looking at the other numbers, the side yet. Side across from the 45-degree angle gets labeled what? L. Side across from the other 45-degree angle. Side across from the right angle. So label your triangle that way. Every time we're going to do the same thing over and over and over again. Fletcher's going to get tired of hearing me saying L times the square root of 2. Huh?
Chew.
Yeah.
Just read, dude, you've heard me say worse today.
Okay. What'd you say?
Fletcher don't. He's just trying to get you in
I
trouble.
know. He's done.
Hey,
Like,
just
just
watch
watch
and
out,
tell
he might
it.
find himself and break you.
Yeah.
Once you have that, once you label it, this is what, and this is where everybody has trouble. This is what I want you to do. Circle the part where they gave you a number. So circle that on your paper. That's the equation you're going to set up. You wrote down something, they gave you some number. You're going to set those two things equal to each other. So this time, what did you write down?
L equals
L. What did they give you?
7.
You're going to set up that equation. This time it's nice. Because what do you have to do to solve for L there? Nothing. So we know L equals 7. So everywhere we see L, what are we going to stick in there? So how long is this side? How long is this side?
7 times the square root of 2.
Those are our two answers. So write those in. And you just leave it that way. That's your answer. Next one, what kind of triangle we got in this one? 45, 45, 90. Side across from the 45-degree angle gets labeled what? Side across from the other 45-degree angle? L. Side across from the right angle? L times the square root of 2. Circle that.
L equals 6.
What did you write down this time? Don't listen to Joseph. What did you write down?
That's what I wrote down.
It doesn't tell us
What did you write down?
L equals the square root of 2.
L times the square root of 2. What did they already have for that side? Now I know Joseph looked at it and said, oh, I know what the answer is, and he's right. But when we get to a harder problem, I want you to know that you got to set up those equations. What do you do here to solve for L? How do you get rid of that square root of 2? Just do what? Divide. These cancel out. What's left on this left-hand side? Over here, what happens to the square root of 2's? Cancel out. What are you left with? So what's L equal? So how long is this side? How long is this side? Now again, could most of you probably pick that out without doing all that extra work that I just did there? But you got to see the process because some of the problems are going to be a little more difficult. All right? And if you don't do the process on those, you won't be able to get the answer. Next one. First thing you know, what's this angle down here?
30.
Side across from the 30-degree angle gets labeled what? L. Side across from the 60-degree angle.
L times the square root of 3.
L times the square root of 3. Side across from the right angle.
2.
This is the one they told us this time, so what's our equation?
L equals 4.
L equals 4. So anywhere we see L, what do we stick in? 4. So how long is this side?
4 times the square root of 3.
4 times the square root of 3, that's one of our answers. This one we stick in 4. 2 times 4 is what?
8.
Those are our two answers. This angle's 90, that angle's 30. What's this angle?
60.
Side across from the 30-degree angle gets labeled what? Side across from the 60-degree angle.
L square root.
L times the square root of 3, good. Side across from the right angle.
2
2L. What's our equation this time? 2L equals 18. How do I solve that? Divide both sides by 2. What's L equal? L equals 9. How long is this side? How long is this side? 9 times the square root of 3. Any of those make sense, Allie? Are you lying to me just so I'll leave you alone? Do you ever lie to me? You liar. Little tougher ones now. Now, Joseph.
What?
Now you're not going to be able to just do what you did before. So these are a little harder, so watch closely on these when we set up these equations. I'm not going to care so much about how you give your answer, whether you give it decimal form or square root form or whatever. So, and we'll talk about that as we go. What kind of triangle is this first triangle?
45, 45.
So we know that other angle is 45. Side across from the 45-degree angles both get labeled what? L and L. Side across from the right angle. L times the square root of. What's the equation we're going to set up this time?
Wouldn't it be the same, just divide?
L times the square root of 2 equals what? Alright, so get that set up. Make sure you got it on your paper there, because otherwise you're going to be lost when you come to these harder ones. And they're not all that real difficult, especially if you let your calculator do all the work for you. How do we get L by itself here? Divide by what? Square root of 2. These are going to cancel out. You're left with L. Now you grab your calculator and you just do it. 46 divided by the square root of 2.
32.6.
32. So 32.7. Oh, 0.5. I thought you said 32.65. So I was rounded up. So 32.5. How long is this side in this triangle then? 32.5. How long is this side? 32.5. Now the other thing that we could do, if they want the answer, but they don't want it in this decimal form, remember we had 46 over the square root of 2, and some of your calculators might do this for you. We talked about it. You multiply the top by the square root of 2, you multiply the bottom by the square root of 2. On top, you end up with 46 times the square root of 2. On bottom, what's the square root of 2 times square root of 2? Square root of 4. What is the square root of 4? 2. Then we can divide these two. And you'll see a pattern here. And if you see that pattern, you really don't have to do this every time. What's 46 divided by 2? 23. So you end up with 23 times the square root of 2. So this side over here is 23 times the square root of 2. Guess what this side is? 23 times the square root of 2. Anybody notice something here? What do you do to get from here to there? Times it by what? Square root of 2. And what do you do to this? Divide it by 2. So you take this and you divide it in half, and that gives it to you. Now the bad thing with that is, on this next one, sides across from the 45-degree angle should get labeled what? And side across from the right angle? What equation we gonna set up? at that over here, you know L is gonna end up equaling, we take half of 15, what's that give you? Nobody knows what half of 15 is?
7.5.
And we gotta times that by the square root of, you could just leave it that way. L equals it there, L equals it
Staff, pardon the
there.
interruption. I just wanted to come on to let everybody know, we just received word from Dark Rule that at 2:40 today, they're going to have to shut the power off for about 5 minutes. So again, at 2:40, all power will be shut off to the building, so please make sure you save anything on the computer. Mostly will impact just the elementary staff because obviously you will still have kids here. But again, wanted to make sure everybody was aware. So please make sure by about 2:30 you save everything and be prepared for it to be shut down for about 5 minutes. So thank you very much.
So we know those two sides are that. You could also give the decimal answer. Somebody help me out, what's 7.5 times the square root of 2? And that would be the two sides. Whichever way you get the answer, I don't care. The bad thing is on the EOC test, I don't know which way they'll have it on there. What kind of triangle we got down here?
60, 90, 90.
Side across from the 30-degree angle gets labeled what? Side across from the 60-degree angle?
L times the square root of 3.
Side across from the right angle?
2L.
A little tougher this time. So make sure you're writing this down. What equation can I set up there?
L times the square root of 3 equals 9.
L times the square root of 3 equals 9.
9.
Not really tougher. If you just divide both sides by the square root of 3. Somebody give me the decimal answer. What's 9 divided by the square root of 3?
5.
Say it again.
5.2.
5.2. So how long is this side in this triangle? 5.2. What do you do to find this side?
Multiply 5.2 times
What is 5.2 times 2?
10.4.
Now, if they didn't want the decimal answer, again, we multiply the top and the bottom by the square root of 3. On bottom, we end up with the square root of 9, which is just 3. On top, we got 9 times the square root of 3. And we could simplify this down. And it ends up, this side ends up being 3 times the square root of 3. That's the same as this. What would you do to get this side, though, if you got to double that?
6.
6 times the square root of, you just leave the square root the same, and you multiply the number outside. Thirty, 60, 90 triangle, side across from 30-degree angle gets labeled what?
L.
60-degree angle,
L times square root
90-degree angle.
of 3. 2L.
What's our equation this time?
L times the square root of 3 equals
Let's just give the decimal answers this time so we can get done with this. What's 11 divided by the square root of 3?
6.3.
6.3? 6.4? How do we get this other side then?
Multiply by 2.
Multiply by 2, somebody do that for me. 12.8. Make sure what always has to be true about the hypotenuse here. It's gotta be the biggest side, right? Is it the biggest side? Yeah. How long is the diagonal in a square with sides 32 centimeters? So if we got this square, this side's 32 centimeters. How long is this diagonal? It's that simple if it's that. What's the area of a square if the diagonal with a diagonal of length 12. Find the area of the square, we take length times width or base times height, right? Well, if we know that this diagonal is 12, how are we gonna do that?
Divided by two.
Do we just divide it by 2 to get each side at 6? Is that gonna work? What kind of triangle is each of these two small triangles?
Square root of 6. No, it's
45, 45, 90. And a 45, 45, 90, how long's, or what's the two sides across from the 45 degree angles get labeled? L and L, side across from the right angle.
times square root of 2.
L times the square root of 2. So what equation can we set up there?
12 divided by square root of 6.
So L times the square root of 2 equals 12. Divide both sides by the square root of 2. Somebody help me out there.
6 with square root of 2 over 8.5.
8.5. So how long is each side in a square?
8.5.
Now how are we going to find the area of it?
8.5
You just take 8.5 times 8.5. What's that give you?
72.
And remember your units, are they just inches? If we're doing area,
Inches squared.
it's inches squared. What's the area of this yield sign? Look, this proves Ebersole is right again.
Yeah, for sure.
Yeah, I was going to say that there was one on our paper.
To find the area of this triangle, we need the base and the height. That 36 is our base. We need the height in here, which we could draw in here, and it's got to form a right angle down there. So what kind of triangle is each one of those triangles on that? 30, 60, 90. That's 30 there, that's 90, that's 60. The side across from the 30 degree angle should get labeled with what?
L.
Side across from the 60 degree angle,
L times square root of 3.
side across from the right angle.
2L.
We know that this side, each one of these sides is how long? So the 2L right here has to be how much? 36. If 2L equals 36, what's L? $18. If L is 18, and we stick 18 in here, that's 18 times the square root of 3. That's the height of the triangle. We need that because we need area equals base times height divided by 2. We know the base is 36, but we need the height. Well, what's 18 times the square root of 3? Give me the decimal answer. So we 31.2. Now you're just going to type this into your calculator. 36 times 31.2 that equals, and then divide that by 2.
561.6.
And our units,
Inches.
squared. That's the area of that yield sign. A tipping platform. Anybody who drives trucks for a living, a lot of times what they'll do on the truck, they'll drive the truck up onto a tipping platform so that the stuff will slide out of the back easier. Now you don't want to drive it up on something too steep because then it all just slides out and it's on the ground all over the place. So they'll drive it up on a tipping platform like that. How high is the end of an 80-foot ramp when the tipping angle is 30 degrees? So this tipping angle right here is 30 degrees. The ramp is 80 foot. That means along the bottom down here it's 80 foot. Well, if this is 30 degrees, what kind of triangle is that triangle?
30, 60.
So that's 60 there. Side across from the 30 degree angle gets labeled L. Side across from the 60, L times the square root of, that side is 2L. all we care about is what L is, because that's what we're looking for, the height of the ramp. This is the equation that we're gonna set up. L times the square root of 3 equals 80. What do you do to solve for L there? Somebody grab your calculator and help me out and give me the decimal answer. 26.2? 46. 46.2. This side's just L, so that's all we want. So it's 46.2 what? Feet. If it was a 45, 45, 90 triangle, what do you expect's going to happen with this height? It's going to be the same as this?
No, it would be 80. Right?
So if this is 80 down here, this side gets labeled L, that side gets labeled L. Dang. That side gets labeled L times the square root of 2. We really don't even care about that side this time. What's L equal? 80. So how tall is the ramp going to be if it's a 45, 45, 90? 80 feet. Probably never ever see a 45, 45, 90 tipping angle there. What would happen to the truck if it's going up a 45-degree angle?
Oh, but it's gotta go.
That would be very good. Last thing here, find the distance from home plate to second base.
I don't have that.
Yeah, you guys don't have this. It's something I just added to it because I like it. So I don't care which one we do. That's a terrible baseball field, but oops, sorry, this should be home plate.
Those 96
Is it
bases are
diamond?
really
What?
looking cool.
So that's home plate.
I'm just creeping me out.
How far is it from home plate to first base? How far is it from home to first?
90.
That's about 60.
How far is it from first to second?
90. 90.
Now, what we want to find is your catcher's sitting here, and they got to throw down there to second base. We want to figure out how far they have to throw.
120,
120.
I believe. What's 90 times?
We could use Pythagorean's theorem, right? But if I could draw this right, if this is 90 and this is 90, what kind of triangle is this triangle?
No.
45, 45, 90. And 45, 45, 90, that side gets labeled L, that side gets labeled L, that side gets labeled L times the square root of 2. What do we know about L? What's L this time? 90. So how long is this side going to be? If L is 90, 90 times the square root of 2. Well, you go out to the baseball field, that doesn't make a whole lot of sense to say it's 90 times the square root of 2, coach. Fletcher will probably do that because then his coach will get mad at him and make him stand back there while one of the crappy pitchers throws and hits him 10 or 15 times.
So all of our pitching, that's happening anyways.
Make him run poles, is that what they'll do?
Yeah.
Somebody help me out, what's 90 times the square root of 2?
What? We're talking about.
Give me more numbers.
2792206.
2792206.
Yeah.
2206. Now watch. I've built, I don't know, 3 or 4 different diamonds where they mess it up. And you have to go back in and redo it all completely. And when you do it, nothing bothers me more than to have somebody in there who has no idea about the math. And they just say, well, it looks like second base should be right about here, so. And they have no real idea, all right? And then you end up measuring it and it's way off and it's no longer a square, it's some rhombus or something else crazy. When I'm looking at this part right here, that's the feet. So I know it's a little more than 127 feet. So if we go out there and we put Joseph's 120 feet down, is that going to be right?
No.
And it's quite a bit off, all right? Joseph's field would look something like my actual drawing here that I drew. What I can do with this part is use that to find the inches, and then we can keep going down just in little bits to get as close as possible. The first thing I want you to do is on your calculator, take this number, it's 2792206, there's a point there, and times it by how many inches are there in a foot? 12. So 1 foot equals 12 inches.
Divide, you said?
Times it.
Oh.
It'd be 335,000, or no, 330.
Did you put a decimal there?
Times 12. It's 3.3506472.
3 point what?
3.506,472.
This that we just came up with, guess what that number is?
Inches.
Number of inches. So it's 127 feet, 3 inches, but we still got a bunch left over here. And that's part of an inch, all right? So if we want to be real precise, which we should probably be, because we don't want to be up to an inch off, that sort of is going to throw the field off, okay? All you do with this,
Centimeters?
what? Now we want to keep it in inches.
Millimeter.
But what we want to do here, because our inches are on our ruler, it goes in halves, fourths, eighths, sixteenths, all that stuff, right? So we can't really give the decimal answer, but you could just sort of estimate it. What do we know about 0.25? That's a fourth of an inch, isn't it? What do we know about 0.5? That's a half an inch. We're between those two, aren't we?
Yes.
So we're at 0.35, which is a little closer to 0.25 than it is to 0.5. So we can sort of estimate that we're in between a half an inch or quarter of an inch and an inch. Let's see what that would be. 1/4 is like 2/8. This is 4/8. So maybe we could go to what? 3/8. That would be directly in the middle. We're not quite directly in the middle. So we could get a little closer than that, but that's probably close enough. So we go 127 feet, 3 and 3/8 inches. That's how far it is from home plate to second base on a baseball diamond. How far is it from first base to third base?
The same?
The same thing. And we probably know Fletcher, he probably throws the ball actually, he's probably about on Joseph's thing, and it probably makes this second baseman and the shortstop mad. He probably throws the ball about 120 feet each time, doesn't he, when he throws it down
If
there?
Joseph would get there in second base in time, we wouldn't have an issue.
Okay, hold on.
You remember last game when there was a runner coming to second and you went hesitated, then you threw it and then he was safe because you hesitated?
Because you two morons couldn't figure out which one needed to come
I
to
was
the
on the
bag.
base, Fletcher. I said,
I couldn't see you down
Whose
there
fault
in
is that?
midget land. I'm sorry. The mouth's taller than you.
tell Gavin, get out.
The assignment's on the worksheet, on the back page. Says, in a 45-45-90 triangle, this is 35 part A. In a 45-45-90 triangle, find the length of the hypotenuse, multiply the length of a leg by what?
2. No,
Close.
Square root of 2.
Square root of 2. That's the answer to that one, square root of 2. In a 30-60-90 triangle, to find the length of the hypotenuse, multiply the length of the shorter leg by what?
2.
That's just 2. It's just 2 times L. In a 30-60-90 triangle, the longer leg is opposite the angle with the measure of what?
60.
60 degrees. Letter D, in a 30, 60, 90 triangle, to find the length of the longer leg, multiply the length of the shorter leg by
Square root of 3.
square root of 3, good. In an isosceles right triangle, that's a 45, 45, 90 triangle. Each leg is opposite an angle with a measure of,
45.
I just gave you the answer, didn't I? I should have read the entire problem before I opened up my mouth. 45 degrees. F, in a 30, 60, 90 triangle, to find the length of the shorter leg, divide the length of the longer leg by
Square root of 3.
square root of 3. Over here it says multiply it by square root of 3 to get the longer leg. To get the shorter leg, we divide by the square root of 3. G, in a 30, 60, 90 triangle, to find the length of the longer leg, divide the length of the hypotenuse by
2. And then multiply the result by, it's 2-parter.
multiply the result by what?
Square root of 3.
Alright. I had to stop and think for a second.
45.
Letter H, to find the length of the side of a square, divide the length of the diagonal by what?
Square root of 2.
Square root of 2. Remember, if it's a square, if I tell you that this diagonal is 7 times the square root of 2, how long is each one of these sides? If that diagonal, they're just each 7. 36. Always, sometimes, or never. So you're just going to write A, S, or N next to each one. Lengths of the 3 sides of an isosceles triangle satisfy Pythagorean's theorem. Never. Oh no, I'm sorry, that said isosceles, didn't it? My fault. Sometimes. I thought it said isosceles. Or I thought it said equilateral. Gotta read careful. The lengths of the sides of a 30, 60, 90 triangle form a Pythagorean triple.
Always?
It's probably not always, but we're going to put always. Because to be a Pythagorean triple, it's supposed to be just whole numbers, none of the rest of that stuff, but who cares? So that's probably not mathematically the correct answer.
Teachers, pardon the interruption. Would everyone please shut down your computers before you leave your room? Again, please shut down your computers before you leave the room.
C, the lengths of all 3 sides of a 30, 60, 90 triangle are positive integers.
Always? Some, never.
They're always positive, but all 3 of them aren't integers because they're always going to have that decimal or square root in it.